Yeah, so before we start this talk introducing the strand of applied data analysis for the humanities, we'd like to introduce ourselves a little bit, because a bit of understanding about our backgrounds is also useful to understand the examples from our research that we will be presenting later on in the talk. So as for myself, I have a background in classics and digital humanities, and I've been working over the past years on information extraction and text mining, especially in the fields of classics and history. And I'm currently a researcher at the EPFL, the École Polytechnique Fédérale de Lausanne. Giovanni?
Yes, thank you very much, Dave, and thank you all for being here. It's really great to see the school going, even though we have this kind of situation on us. So my name is Giovanni Colavizza, and as Dave was saying, I used to be until last year part of the Alan Turing Institute, the research engineering team. And before that, I have background in computer science and history, which will surface a little bit today as well, and in this course. And presently, I'm assistant professor of digital humanities at the University of Amsterdam in the Netherlands.
Okay, so about the structure of the talk, I'll be presenting last year's strand at the beginning, and then we will showcase two examples from our own respective research. We'll conclude with some pointers to the materials we have, and then there will be the Q&A session where we can ask your questions, and we'll be happy to discuss. So last year was the first edition of the Applied Data Analysis strand, 2019. The strand at the beginning was quite successful. We were told was a second strand to be booked out. The size of the strand was quite good. We had about 20 students, and they really showed mixed backgrounds in their profiles, and also they were coming from different career stages. We had postgraduate students, professionals already working in libraries, so very different motivations to be taking this course. And it's an advanced course, meaning that we assume already some familiarity and some proficiency in Python, which is the language through which the course is taught. And also on that side, we had quite a variety of different levels of proficiency. So let's unpack a little bit the title of Applied Data Analysis in the Humanities. So what we mean by applied is that we will foreground techniques and methods over the implementation. So our focus is more on the effect, on what is done by these methods and techniques, rather than how they are actually implemented. But this doesn't mean that the theory behind the tools and the technique is not important. And instead, it's really essential to be using these tools, these techniques, and these methods with awareness about how they're actually working, but not necessarily how they are precisely implemented. Data are central in the course, of course. Typically, we use data sets that are too large to be processed manually, or and also they are too large to be analyzed manually. Manually being, for example, by qualitatively or by close reading, without the high risk of introducing a bias. On the analysis is all about getting insights, interesting insights about our data. At the starting point, there is always either an information need or a motivation or a research questions to be using a certain type of data. And via the data analysis, we help creating these new insights and knowledge about the data that we are analyzing. Things that are also relevant about the strand, but not necessarily in the title, is by humanities really cater to a wide array of users, going from scholars to professionals to practitioners in the field, covering potentially the whole spectrum of the humanities. And as I said already, by advanced, we mean that some knowledge about coding, and especially coding in Python, is a requirement to be taking this course. in this Venn diagram, you have a bit the overview on the skills that come into play when doing data science. So you have the expertise about the domain of application, hacking skills, in our case, coding proficiency, and then you have the theory, in our case, the mathematical and statistics knowledge, which is necessary to apply data analysis methods with awareness. And at the beginning of the strand last year, we had students a bit reflecting on this diagram and also saying how they felt they were positioned. And interestingly, quite a few were either in the danger zone or in the traditional research. So either lacking the theory for using the hacking skills, or lacking these hacking skills. So our goal during the course was really kind of to move them from these two areas of traditional research and danger zone towards the data science overlap of these different skills. We borrowed this diagram from the R for Data Science book by Wickham to basically guide the way we structure the course, and also to guide the schedule through which the course developed. And you have here the different phases of a typical data analysis pipeline or process or workflow, which usually starts with importing data for the analysis. This can be already existing data, or data that come from, so for example, metadata, or data that come from some actual processing. Then there is a phase of tidying up the data that basically means transforming the data from their original form into a form that is suitable for the analysis. And then you have a loop where 3 different steps allow you to get a better understanding of the data. And these 3 different steps that work in a loop are transformation, visualization, and modeling, where transformation is often needed to go from the tidy form of the data to a form that allows you to visualize them. Modeling, it's necessary and useful to explain and understand the data. And then this leads to a cycle where visualization can lead to ideas for the modeling that turns into a new transformation required to produce another visualization, and so on. And then at different points within this cycle, you have communication, where visualization tools that we also teach in the course are useful to communicate insights that we gain from the data in the context of scientific communication. So, well, I didn't say that, but the usual joke about data science is that the import and tidying and transforming part of the work, it's usually up to 80% of the job of data science, where the remaining is like the 20%. But that's an really important part of preparing the data for all the analysis that comes afterwards. So in the schedule, we start from importing. We go basically through all these steps in the workflow of data analysis, starting from the importing, then revising the Python skills that are necessary to master the libraries that we are using for the data analysis, like pandas or seaborn. Then we go in depth into the wrangling, so transforming data into and from different shapes for the analysis, for visualization, and for other needs, and then go into the real exploratory data analysis, visualization, and modeling. And the course was structured having in the morning a mix of frontal lessons by us, together with interactive session done via Jupyter notebooks. And then in the afternoon, we had optional sessions where students could come to get a mix of things. So I was either for the troubleshooting, so if I had problems with the technical setup or specific questions or points where they got stuck. And they were also dedicated for the students to work on their own projects. So either they could come with their own data to analyze and develop this as a project during the whole course, or we will also propose some data sets to work with, and they could pick any and then use the afternoon sessions to use this data set to go through the materials from the morning. Speaking of data sets, this is what we proposed last year. And as you can see, there is a wide variety of types of data sets, going from time series to metadata containing metadata and text, to numerical data or network data, and also covering a wide range of areas, going from film studies to history and contracts of apprenticeship in Venice, to crypto art transactions. So anyone could find something interesting for their taste to work on during the strand. So I'm gonna now to present the first example of data analysis drawn from my own research, and especially from some work that I did on extracting the canonical references, that are references to primary sources from all articles contained in JSTOR, which is a large repository of scholarly publications. The main motivation for doing this is that this type of references, of citations, can be used as a proxy to track over time a scholar's interest and attention. Every time a scholar is citing a work, it's leaving a trace of their interest in this work. So the type of data that I was dealing with in this specific case comes from data that originates from processing. So here on the left-hand side, you have, for those that are not familiar with classics, an example of what these canonical references look like. They are basically these sequences here of like Odyssey 1 to 4, Homer's Odyssey, Book 1, and so on. So they are all very punctual references to works that are discussed sorry, in a publication. This is how they look like, and they were extracted by means of an NLP pipeline that I developed that was going from plain text, completely unstructured input, looking a bit like the text on the left, and was outputting the same text with annotations expressing in a machine readable form the passages that were cited. This was then applied to the whole publications in JSTOR, resulting in quite a large number of canonical references extracted. It's over 1.5 million, and as you can see, also quite a lot of articles and large size in terms of text that was processed. I'm showing these plots to get a bit of a sense of how the data distributes. So you can see, for example, in terms of the number of articles, they increase in the numbers after the 1960s, show you how the data will distribute when you analyze them. And also, it's extremely interesting for the use that one can make of the outcomes of the analysis is the language distribution. So the language distribution in JSTOR is very biased towards the Anglophone sphere, where you have almost 75% of articles that are written in English. And this is quite different from the reality in the sense that in classics, instead you have other national languages like Italian, German, and French also having a big share of yearly publications in the field. So this is important when taking the results of the analysis and generalizing them as representing and as being representative for the whole classes. So the first thing I wanted to present is an interactive data visualization that I produced starting from this data. The main goal of this visualization was really to showcase and explain how the canonical references extracted could be useful to scholars and students in the field. And that's actually one of the functions also of the visualization in the context of scientific communications, of giving a sense, giving an intuition about the usefulness of someone's data or research. What this visualization represents are all data about references and quotations that were extracted from articles in JSTOR, either by means of my citation mining pipeline or by means of text reuse detection that was done by the colleagues in the JSTOR labs. So all the data that is represented here and was extracted are places where a given passage of the N8 is referred to or it's quoted. And the idea of the visualization is to bring in different levels of analysis of the data into the same interactive environment and allow you to go from one to the other in exploring this data. So what you have in the left-hand side is a heat map representing the density, basically, of references and quotations as they distribute over books and chunks of lines of the N8 written by Virgil. So the more colored a given cell is, means the higher is the number of references and quotations that were received. In the main column, you have the text that brings you from like the distant reading that you have on the left column about how these citations distribute to the actual text that is referred to, so you can read it if you read Latin, and then so it's a close reading view on the primary literature and on the right hand side you have a close reading view on the secondary literature. So on all the articles that are citing or quoting Homer's Iliad. So here the visualization can guide the attention. So one can go from the areas of the text that were more discussed and then see where in the text they are cited and referred to. But this is a rather synchronic view on the data, whereas it's also quite interesting to analyze this data diachronically. So what one can look at is the reception over time of different authors. In the whole data that I extracted, there were more than 1,500 authors. So I had to select some examples from the from this canon to focus on, and Ovid and Virgil gave a good example. And I was inspired especially by an article by Theodor Tsiolkovsky on the reception of Ovid and Virgil in literature, not in the scholarly literature, but more in the novels across, throughout the 20th century. And Tsiolkovsky argues basically that Ovid and Virgil, they represent two polarity. So one is Ovid is the poet of the freedom from politics, whereas Virgil, for example, is the poet of the love for homeland and fatherland. And he's arguing in his essay that the reception in the literature of these two poets is always mutually exclusive. So some periods are either Ovidian or Virgilian. So I compare this idea also with the scholarly literature using these canonical references as a proxy. And it's interesting to see how some of the phases that Tsiolkovsky has found for the literature, they are also found in the scholarly literature. So showing some symmetry for this influence. But more work is needed to be done, especially to reflect the fact that in JSTOR, you have a strong bias for certain languages. And I'm going to hand over to Giovanni for the second example.
Thank you very much. Can you see my screen? I hope so. Okay, so thank you, Matteo. And I'm also going to start with another example of applied data analysis, and just reminding again what is the purpose of these two examples that we're giving, one each. It is primarily to illustrate some of the tools and techniques that we try to teach in this course. So the idea is, I mean, you can find, of course, the case study compelling and of interest, but that's of secondary importance. More importantly, is to show you some things that you can do with the skills learned at the course. I also would like to mention that someone asked about the slides. I believe they are in Canvas, but they might be still not yet available. So maybe someone from the support team could take a look at that, because they should be there. So my case study is quite timely in a sense. It's a study of a pandemic, of really large plague outbreak that happened in many places in Europe, and especially in northern Italy in 1630 and 31. And primary focus of this study is Venice. Study the city of Venice, which was really badly hit. You may find a preprint of this work online in medRxiv following that link. So I'm taking from that one. If you want to know more, that's the place to go. Now, let me first start with data collection. Right? To do data analysis, we really need to do data collection, and this is something that we really cannot and should not overlook. It's usually costly, complicated, and we really, at the very least, need to be aware of that. So even though in the course Applied Data Analysis, we focus on the analysis, it's always important to keep in mind that data doesn't fall from the sky, but it is collected, and we need to be aware of how it was collected, what is the quality, and which kind of data we are dealing with. So in this case, we worked with so-called death records. So death records are something that is relatively common in Europe in early modern times. Of course, they can survive or not. And what they are is registrations of people that died. In Venice, these records were particularly well kept and also detailed, and they look like you can see here. So small books that were kept for each parish. The parson was in charge of keeping them, and then the public offices were also keeping a copy, where everybody that died was registered with their name, age, and the reason for the death, as well as profession, and sometimes even more information. So what we did was we wanted to understand really the dynamics of the outbreak, and we decided to essentially collect all the surviving records between 1629 and 1631, so over 3 years. That's quite a lot of records, and we did this first by digitizing them, but then secondly by manually transcribing part of the information that they contain. So we transcribed all the number of people that died, and for some parishes, even all the details that were reported to conduct this study. And the result is that we could find slightly above 43,000 persons that died in 3 years. Now, for reference, you need to imagine that the city of Venice these times had an estimate of 140 to 160,000 people as residents. So it's quite a staggering number. And I'm simplifying this work really in one slide, but it took a couple of years to do actually in practice. And assuming that now you have this data, you can start analyzing it. And things become immediately of interest. Even something very simple, such as a time series or a timeline of how many people died for every day in these 3 years, is very revealing. So we see here that the main outbreak of this plague epidemics happened in the fall during the autumn of 1630. And that by the beginning of 1631, it was fading away big time. But you can also notice that from January 1631 to September 1631, so for 8-9 months, we still have a very high mortality. And we also checked, and we still have cases of plague. This is something that was not known to historians, because no one did analyze the full extent of these records. So we saw something that we could not relate to previous art. A big peak, and this is known for plague epidemics, but also a long tail of high mortality that we could not explain. And we still cannot, by the way. I mean, we're still working on this. And then next, we started to delve deeper, right? So, for example, we checked which deaths were reported as being plague or not plague. That's the plot that you have on the bottom left, or B. And we noticed that there was a systematic self-censorship, probably, in the part of people that were registering deaths at the very beginning of the outbreak. So they were reluctant to say that this is plague, right? Maybe they were in self-denial, or maybe they were afraid of the consequences of reporting that, because very strict quarantine was put in place, and that was not really nice to accept for the population. It rings a bell, I suppose, for all of us now. We can also analyze, of course, the geography. If there is any geographical correlation with the outbreak unfolding. You can see on the right a heat map of the number of deaths for different parishes in Venice. And what we could notice is that there doesn't seem to be any effect on the location. So this seems to be an outbreak that happens everywhere in the city, as if it were a fully connected world, which was very much the case in Venice. With data analysis and visualization techniques, we could also check, and also some hypothesis testing. So all these are topics of the course, of the applied data analysis course, of course. We could also check a few other hypotheses. For example, we found that apparently there was no significant difference between genders in terms of the length of the sickness, both for deaths due to the plague or not, and also for the age of death. Instead, there was indeed a very, very significant effect on the plague on different age groups. So this you can see on the bottom right, or table D. You can see that the plague strikes struck very badly children and the young, and especially adults. While instead the patterns of mortality for non-plague related causes are very, very different. And this is why it's yet another reason why it was particularly bad, because it was hitting the adults and the working population. And then lastly, what I would like to really underline is that no matter how detailed and well kept were these records in Venice, really we don't have the full picture. For many parishes, we don't have records. You can see them in gray here. This is a map of Venice. With the parishes for which we have most records being colored or even mentioned by name. So it's still a fragmentary picture that we're dealing with. Yet it's quite a rich one. So we were able to confirm that it was a huge loss in population, roughly 30–35%, with a peak, but also a long tail. No gender or location effect, but significant age effects. And now we are focusing on the economic consequences of this outbreak, because we also have other records that are quite interesting in telling us about the economic life of the city. And this is really a natural shock. It's exactly as it is happening for us now. We can study the before and the afterwards, and how people and the government adapted to the shock. And to conclude, I would really like to underline that while this is quite rich, and with the tools that we learn on the course, we can already find quite interesting patterns in the data. This is by far and large not sufficient to come up with an interpretation and with a conclusive understanding of what happened. There are many more and other sources that needs to be considered in the archives in Venice and elsewhere. So this is a complex phenomenon. But at the same time, I think the use of systematic data sources, so the data sources that are serial and for which we can really analyze, perform an analysis systematically, are really important in providing a baseline and providing evidence that it's really difficult to grasp in its full extent using small samples or qualitative methods. So yet again, we are back at using combination of methods. We need to really combine them in order to get a better understanding of this phenomenon. Which brings me to a conclusion, and also a bit of motivation for this course, I would say. This course, Applied Data Analysis, aims to deliver not just technical skills, which are very important, right? So how to code in Python, how to do visualizations, and how to do hypothesis testing and all that kind of stuff, tidy data. But it is also an attempt to start to convey the kind of thinking that we need to have in order to work with this data, and especially the thinking that attempts to combine a solid statistical understanding of data that can be analyzed, so of sources that can be analyzed as data, with also the necessity to keep contextualizing them, to keep putting these results in broader context and in relation with other data, with other sources. And if you like, this is a bit conveyed into this plot, which is casting using two dimensions. One is the size of the data. The other dimension, smart data, is more about, I like to think, how well data is structured, is understood, is contextualized. And I think us in the humanities are very used to working with smart data, often relatively small data, and we invest a lot of time in curating it and understanding it. And the opportunity and the challenge which this course is try to skill students up for is that of combining the best of both worlds. So enlarging the amount of data that we use, trying to have more systematic understanding of the patterns that are out there, but without compromising on the quality of the data and the importance of the context. And yes, this is it. Very last slide. So if you want to take a look, if you even want to use the materials of the course, you can just do it immediately. Everything is online. Everything is published with an MIT license. So you're welcome and encouraged to do anything you like with them. You can even run them online. You don't need to install anything complicated using Binder. Just follow that link and yeah, let us know if you have any feedback and if you like it, or even if you don't, and if you have something that you'd like to see improved, we are very happy to know about that as well. And I think that's all from us. We can take any questions you like now.
Thank you very much, Giovanni and Matteo. That was great. We have quite a few questions and discussion in the chat around the overall course, but there was also a specific question on Giovanni's presentation. So I'm going to go to that first, and then we'll go to the more general ones. Also to note that your slides are now available. So there's a question from Leah to Giovanni. How do you know that people were censoring the cause of death? What were they reporting instead of plague? How do you know if it was false reporting? Can you say a little bit more about that? I like this. It's a good example of interpretation and critical analysis of the data.
Yes, so this is an excellent question, so I would still qualify that as a speculation or hypothesis to be further studied. Having said that, there are a couple of things. So one is that staying within the data that I've discussed, what we see is that there are a lot of very vague and general causes of that are reported at the beginning of the epidemic, such as fever, for example. Right? A huge amount of people dying out of fever. So the lack of detail and the grouping of everybody together, huge numbers into very general categories, might hint at the fact that these were accounts done in batches. So sorry, it's a bit somber, but essentially registrations done maybe once a week of a lot of people, and then they were just going fastly and just going rapidly through all of it, and so possibly they didn't know, but that's very difficult to trust because as an interpretation, because we know from other sources that way before the start of the epidemic in Venice, the authorities were well aware that it was coming. Because it came from the borders of the main Venetian mainland, from imperial armies coming down to fight another war, and they were trying to prevent people coming to Venice. So they knew that it was coming, And at the same time, we are witnessing a high amount of very general causes of death in the very moment where we know from other sources that we're discussing that a lot and people are very afraid. So this is why I think it might be a valid speculation to do, but it needs further work.
Thank you very much. So some questions about the overall course. So a great one, and I didn't clarify this, and you'll be able to do it much better. People have seen a talk from the Text to Tech team, and I wonder if you could say something about the differences between the two courses, because they are related.
Matteo, would you like to take this one?
Sure. I think in our course there is we spend much less time on learning Python. So Python is used a lot. We spend a bit of time revising main concepts and data structures, but it's not a course where people can come and learn Python. So that will kind of disappoint them. I think there is a great amount of overlap also, in the sense that things that you can potentially do in the other end that could be analyzed and explored in the data analysis trend, but we focus much more on the tool set, let's say, that you need for the analysis. So understanding a bit the statistics, exploratory, descriptive statistics, the visualization, manipulation of the data, tidying up. So that's much more focused on what you need for the analysis, I think.
Thanks.
Yeah.
Sorry.
No, go ahead.
I think it's a good example of the range of strands in the summer school, some of which are more advanced than others. This one deliberately is advanced, and we make the prerequisites clear. But this point about learning Python has had quite a lot of discussion. I'd like to revisit that. And we had a discussion earlier in the week, basically around, do you have to know Python to do DH? To which the answer is no. But there are some things you can do with Python. Some things in DH where it's very beneficial to know Python. And actually, you've illustrated very well a couple of those things. So if you were coming to this afresh and coming to summer school for the first time and asking yourself, how do you know when you need to learn Python? How can you tell in your DH project that you need to go on a Python course or not? What do you have any advice for people as to when that background is needed?
Giovanni?
Well, I think so. I'll maybe be a bit provocative here, but I think, well, not that everyone needs it, but I would reverse the question around. So when is it really not needed? Because nowadays, it's really, there are so many data sets and so many opportunities that would allow someone with the skills to apply them in a meaningful way and a helpful way, that I would even just to work in their own data and in their own records for personal purposes, just processing files, extracting things, and ordering your own archive. I think it's quite helpful. But I would also say that I don't think it's really unachievable and too complicated, right? Because basic Python skills, it's something that can be achieved with a little bit of effort. And then with minimal skills, I think something really amazing in the digital humanities is that we can jump into doing useful things, very interesting things, rather quickly. So I would encourage everybody to consider why not, right? So why not having them? Because it's very difficult in the future to say, well, will I need them or will I never need them? I think never is a strong word. So why not?
Thanks, Giovanni. Matteo, did you have a comment on that as well?
Just wanted to add that I will say one needs to distinguish between learning Python to do the things himself or herself in the project and learning Python as one will learn another modern language to understand another culture. And I think here, by learning how to program and how programming works and means and what is data, what it does to the data, it's useful to have an exchange with other research communities, with people in informatics, in machine learning. So it's not just about learning programming to get things done, but it's about learning programming to learn the concepts behind computation.
Thank you. I'm just going to tie some of this discussion back to earlier discussions in the week, and there's a really, I think, an interesting point there. Back on the first day, where I sort of boldly asserted that in the future we won't need to have the word digital in front of humanities; it will just digital humanities will just be humanities. John Stell on the questions sort of said, "But isn't DH another way of thinking, or a way of thinking?" And my answer to that is partly yes, and it relates to what you just said. There is a kind of computational way of thinking that I don't want to see it as an alternative to anything else. I just see it as one of the tools that we embrace in DH. But what you've just said has highlighted the benefits of this way of thinking, that sort of computational approach. I think that's what comes through in your courses. So perhaps that this is consistent with what you just said then, and Giovanni's sort of strong position there, that actually this is part of our toolbox and I think our way of thinking as well. But I have another question to tie it back to earlier in the week. So someone on the chat has asked, did you use any specific language, e.g. XML, for the text transcription and digitalizing? And one of the reasons I'm going to just pick on this one is that earlier in the week, on the first day, we had a talk on TEI, then we had a talk on text-to-tech. And then someone said, so is it better to use TEI or not use TEI if you can do text analysis? Which is a great DH question. So it's sort of revisiting that. What did you do in your projects? What sort of text encoding are you using?
Well, I can say what kind of text encoding we use in the course, and maybe you want to elaborate then, Giovanni, on your specific project. So in the strand, we try to expose participants to work with potentially any type of text, but type of encoded data, but we work especially with CSV, JSON, and XML. So at the very beginning of the course, in the importing part, we present libraries that allow them to work with data in different shapes, in different formats, and how to manipulate them in a way to make them analyzable. It would be nice to have all data about text encoded in TI. The reality is often different. So one needs to be able to cope with XML when XML is provided, but at the same time also to be able to parse like incorrect CSV or not properly encoded JSON and these kind of things that are kind of more real life scenarios we encounter.
Thanks, Matteo. Giovanni?
Yeah, I think I've not much to add, especially for that project, because I mean we use Excel spreadsheets and then we converted that into pandas tables, right? So there is no magic there, and we could have done something different, but that works pretty well as well. So we didn't follow any standard for that, but in general, yes, what Matteo said. Brilliant.
Thank you so much. We're out of time now, and our next speaker, Sam Blicken, who's based in Chicago, has just zoomed in. So we're going to go and prep her. Thank you so much for that talk. And there's much in the chat that our speakers can follow up with, and there's more general discussion there around introductions to Python and to some of the topics in the talk. And I'm sure our speakers will take a look through that. Thank you all so much. We're going to take a 15-minute break now and return at midday. Sam Blicken is going to talk about crowdsourcing the humanities, just like I crowdsourced the question about introductory DH textbooks in the chat earlier. So see you back in 15 minutes. Cheers.
Thank you very
again
much
to our speakers.